do is you want to go back and review something that you may not have done for a long time, and that's long division with numbers. And the reason we're doing this is not because this is the main topic, but it's to get us to think about long division once we get to polynomials, which is what we will be doing tonight. So let's start out with a little bit of review here. 1,579 divided by 32. If you remember, the 1,579 goes into our little division symbol there, and the 32 goes on the outside. Okay, so once we see that, our goal is to figure out how many times 32 will go into this, right? So we first of all look at 32 into 1, and obviously 32 doesn't go into 1. And 32 does not go into 15. 32 will go into 157. But the question is how many times? So a lot of times we'll estimate, right? We'll think, well, this is about 30, right? And 30 would go into 150 5 times. So let's check that out. And we come over here and we take, okay, 32 times 5, and we have 10 carry the 1, and we get 160. So it's just a little too big, right? So we can't use a 5. We're going to have to use a 4. So 32 times 4 is going to be 8, and 3 times 4 is 12. So we get 128. And we put that underneath there. And does anybody remember what we do after we put that number underneath there? You subtract it. That's right. So we subtract it. Now I do want to make sure I put my 4 up here. And then we subtract. And so I need to borrow from this 5 and make it a 4, and that's 17. So we're going to get 9 and a 2, and that's good. Then we bring down another 9, right? And then we think, well, how many times will 32 go into 299? Well, it almost went into this 5 times, right? But we had to make it down to a 4. So that means the next one's probably going to be a 9. So not that you have to even worry about this. This is just to get us thinking about long division again. So this is 18, carry the 1, 288. 288, and then again, we subtract, and we get 11. So this was a 9, and then the 2 ways we're going to write our answer. If you go back to way, way back when you first learned division, when it didn't come out evenly, sometimes we would write this remainder 11. Do you remember doing that in the past? Okay. So that's one way we could have written it, or the other way we could have written it was 49 and 11 over the number we divided by, over 32. We could have written it as a fraction. And those are the 2 ways that we're going to be writing these when we do polynomials. Okay, I know with numbers you can add a decimal point and then just keep dividing. We can't do that with polynomials, so we're not going to worry about that, which we're either going to use remainders or fractions when we write our answers. Okay, so that's just a little bit of review. Keep that in your mind because we're going to go on to our next slide. And when we go on to the next slide, we're going to, well, yeah, there's our answer. But when we go on to the next slide, we're going to do this division with polynomials. All right. So this time, in our little division symbol here, we're going to have our x cubed plus 4x squared minus 5x minus 14. And then on the outside, we write down the x minus 2. Okay? Everybody okay with how we set it up? Now, here's the difference. We can't estimate how many times x minus 2 goes into that big thing because we have no idea how to estimate that. So here's what we want to do. We want to, as we're working along, we want to cancel out one term at a time. And so here's what we're going to do. We need to turn this x into an x cubed. Okay? And we need to use multiplication like we did with the numbers. So what would we multiply x by to turn it into x cubed? Some of you are looking at me like, how am I supposed to know that? Okay, well, practice, you'll get it. But if you're not sure, here's how we figure it out. If I want to know what to multiply by, I take this x cubed that I'm trying to get to, and I divide by the x that I already have. And what do we get when we divide x cubed by x? X squared. And so that is what we are going to multiply by. I'm going to put that x squared right above that x squared. And so here's how we do this. We know we're going to multiply by x squared. So we're going to take x squared times this x minus 2. Just like we did with the 32, right? And when we multiply this, we have to distribute. So x squared times x is going to be x cubed. And then x squared times negative 2 is negative 2x squared. Is everybody okay with multiplying this times this? Now we're going to take this and we're going to put it under here. X cubed minus 2x squared. Okay. Now what did we say when we did this with numbers? Once we wrote it under here, what did we do?
Subtract.
We subtract it. So here's the deal. It's a little bit trickier, but we are going to subtract it. But because there's two pieces, we want to make sure we subtract both of them. So here's how we make sure that we subtract both of them. We're going to draw the line and change the signs. So we're really adding the opposite, which is the same as subtracting. Okay, we want to change all those signs in that number that you just wrote down. Okay, so then look at what happens to these x cubes. What happens to them? X cubed minus x cubed, they cancel. That's exactly right. And that's the goal. We want to cancel out one term at a time. Now we take the x squareds. What happens when we add those together? What do we get? Yep, 6x squared. And we bring down the minus 5x. And we can go ahead and bring down the minus 14. And we're going to do the same thing again. We want to turn this x into 6x squared. So if you're not sure what to use, we can come over here again. We're trying to get to 6x squared, and we already have the x. So what do we get when we divide those? Six x. So that's what we're going to use next, 6x. So we're going to come over here. We're going to multiply the 6x times the x minus 2. We need to distribute. So this gives us 6x squared times the negative 2 gives us negative 12x. And we're going to put that under here again. So 6x squared minus 12x. Okay. Once again, when we get to this point, we want to subtract. So what do we do to help ourselves remember to subtract both of these parts? Draw the line, change the signs. Okay, remember that little phrase. I'm going to keep saying it over and over again. You'll get sick of it, but that's fine. Hopefully it'll help you remember to do it. What happens with the x squareds? They cancel, right? That's the whole point. So they better cancel, but they do cancel. And then what happens with the x's? What do we get there? Yep, 7x. And we're going to bring this 14. Okay, and we do the same thing one more time. How do I take this x and turn it into a 7x? I think we can get this one just by thinking about it. How do I take the x and turn it into a 7x? What should we multiply by? 7, right? We don't have to do this if we know the answer already, so plus 7. And we're going to multiply 7 times this x minus 2, and that gives us 7x, and that gives us minus 14. So we write down our 7x minus 14 under here. At this point, again, we want to subtract, so we're going to draw the line and change the signs. And what happens with the x's? They cancel. They're supposed to cancel. And actually, in this case, what happens with the constants? They also cancel. So in this case, our remainder is 0. And so this is our answer. X squared plus 6x plus 7. And our remainder, if we had to write it down, I know sometimes on the homework it'll have a box for the quotient and a box for the remainder. So your box for the quotient would be x squared plus 6x plus 7. Your box for the remainder would you'd put in a 0 because there is no remainder. It's just 0. Okay? Is that Make sense? All right. Now, we're going to use that information to help us find the x-intercepts of, notice this is the same as this, right? So here's what we just figured out. We just figured out, I'm going to erase some of this. When we did that division, we just figured out that x minus 2 times x squared plus 6x plus 7 is equal to that. Does that make sense? If I ask you to do, let's just say, let me make up a number here. 21 divided by 3. And the answer is 7, right? That means 3, the number divided by, times 7, our answer is 21, right? So that's what we're doing here. We took this thing, divided by x minus 2, and the answer was this. So that means these two multiply together to equal this. Okay? So we can use that fact because it's asking us to find the x-intercepts. And when we're finding x-intercepts, we want to factor it and set it equal to 0, right? Which now we've got it factored already. So we got to skip that step because we already did it in example 1. Okay? So at this point, we take this x minus 2 and set it equal to 0. And we take the x squared plus 6x plus 7 and also set it equal to 0. And what do we do here?
Plus 2 on each side.
Yep, add 2 on both sides. So x equals 2, which means our intercept is 2, 0. That's one of our answers. Okay. Now on the other one, unfortunately, we look to factor it. We do 1 times 7, which is 7, and it's a positive 7. And we just did that factoring unit, right? Just took the test on that. It's positive 7, which tells us what about the signs of the numbers we're looking for? They're both positive or they're both negative. It means they're, positive, positive, or negative, negative. And then we look right here and we find out they're positive. Well, the only options are 1 and 7. And if they're both positive, the problem is they don't add up to be 6. They add up to be 8. So we can't factor this. So what's our other option if we can't factor? I know. It's the one you guys don't like. It's a quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And we're going to have to use that to solve this second equation. So let's remind ourselves, what is a? 1. It's the number right here. What is b? 6. And what is c? The 7. That's correct. So then we're just going to plug these numbers in. X equals, actually, let me do this over here. X equals the opposite of b, which is 6, plus or minus b squared. So again, 6 squared minus 4 from the formula times a, which we know is 1, and c, which we know is 7. And then again on the bottom from the formula, 2 times a, which we know that's 1. So we just took all the a's, b's, and c's and plugged them in. Okay. Now we need to simplify. So remember, we have to take a couple steps of simplifying. Opposite of 6 is negative 6. 6 squared, 36, minus 4 times 1 times 7 is 28 over 2. And if we simplify that, it's going to be negative 6 plus or minus, and 36 minus 28 is 8. And I'm going to go ahead and separate this because we're going to have to simplify this anyway. Oh, you can't see that on the video. All right, let me write it under here. Okay. So remember now we want to break up this 8. So we can break up 8 into what and what?
2 and 4.
2 and 4. And how do we break up? The 2 is done, but how do we break up the 4? 2 and 2. And so remember, when we're breaking that up with the square root, we're looking for pairs. So we've got a pair of 2's, and then we've got a 2 left over. So this is -6/2 plus or minus. A 2 can come out because of the pair, and then another 2 stays on the inside. And then we just reduce. So -6 divided by 2 is what? -3 plus or minus. And then these 2's cancel out, so all we have left there is square root of 2. So remember, that's 2 answers. So our other 2 intercepts are -3 plus the square root of 2, comma 0. And then -3 minus the square root of 2, comma 0. So notice here was one of ours, our x-intercepts, and here are the other 2 x-intercepts. So we have a total of 3, which makes sense because the degree is 3, right? And that's how many we could have. If the degree is 3, we can have up to 3 x-intercepts. So really, this stuff was all review from what we did last unit, I guess. The only part that was new was that we did example 1 and we divided it first. But we can do that division and find some factors and then use what we've used already to help us answer the question. Okay. What other questions do we have on that? All right, well then we're going to go on. But there are our answers at the bottom there. All right, now we are going to divide this one using long division. All right, and just a reminder, if they ask for x-intercepts, make sure you write it as those ordered pairs when you put it into your assignment answers. If they just ask for solutions to the equation, then you're just writing like x equals 2 or x equals whatever those answers were, -3 plus square root of 2, -3 minus square root of 2. You don't put in the ordered pairs then. Okay? And it'll usually, like in red letters, it'll usually say this is not written in the right form or something like that. So just be aware of that. Kind of pay attention to it. What goes into our division sign here when we do this? On the inside will be
2 cubed minus 7x.
correct. Now I'm going to add one more thing in here because if you notice, there's no x squared term, right? You see that? There's no x squared term. So just to keep everything lined up, I'm going to put in a 0x squared. It doesn't change it because 0x squared is still 0, right? But it's just to keep everything lined up nicely. Okay. And then on the outside goes the x plus 3. Okay. So we've got it set up. Remember, our goal is to cancel one term at a time. So what will I have to multiply x by? Let's see if we're getting better at this. What will I have to multiply x by to turn it into 2x cubed? 2x squared, correct. So we're going to put that 2x squared right up here. And we're going to multiply 2x squared times x plus 3. And we distribute, and we do get 2x cubed. That's what we need. And then we're also going to have plus 6x squared. And that goes under here, 2x cubed plus 6x squared. Now, what do we do once we write that underneath there? We need to subtract. So we're going to draw the line and change the sign. So these both become negatives, which is good because then 2x cubes will cancel, right? One's positive, one's negative. And then you've got 0x squared minus 6x squared, and that's negative 6x squared. And we bring down the minus 7x, and we bring down the plus 3. Then we need to do the same thing again. What do we do to the x to turn it into a negative 6x squared? What are we going to multiply it by? Negative 6x. That's correct. Good. So negative 6x times the x plus 3. We distribute. We're going to get negative 6x squared, just like we want, and this will be minus 18x. So negative 6x squared minus 18x. And what do we want to do after we write that down? Draw the line, change the signs. So now, once again, we have a negative and a positive 6x squared, so they will cancel out. A negative 7x plus an 18x. What does that give us? Negatives? 11x. That's correct. And then we'll bring down the plus 3. Oops, plus 3, not 33. Okay. Then once again, we need to try and cancel. So what do we multiply x by to turn it into 11x? $11, right? So plus 11. So like I said, you don't have to do that division every time. If you know what to multiply by, just multiply by that. But otherwise, if you're not sure, go ahead and divide it. So 11 times x plus 3 is going to be 11x plus 33. And then we need to subtract. So we will draw the line and change both the signs. So this will be, the 11x's will cancel, and this will be minus 30. And then minus 30, so here's when we get to this point, once this degree is less than this degree. So let's review a little bit about degrees. What's the degree of this one? 1. And what's the degree of this one? It's actually 0. Okay, if there's no x, it's a 0 degree. So degree of 1, degree of 0. When this one degree is less than this degree, we stop. So that means our remainder is negative 30. Or you could write it as minus 30 over this divisor here, x plus 3. Remember, if you're going to use the fraction, you put the number on the top and then you divide by, the fraction part is what you're dividing by. Okay. So that is that one. So hopefully you got the right answer. Yep, remainder negative 30. And again, sometimes they'll have separate boxes for these, and sometimes they'll say to write it as a fraction. So just make sure you read the directions on how they want you to write the answer. Okay, but there it's the same thing. It's just how you write the answer. Any questions on that one? All right. So we're going to learn an abbreviated version of this, kind of a shortcut that we can use sometimes. We can't always use it. Remember how we had shortcuts when we were factoring, and we could only use it when the a value was a 1? Okay, if the a value is anything other than 1, we had to do the longer method of factoring. Well, it's kind of like that. If we do this, and we're dividing by x plus 3, we can use what is called synthetic division. This is our shortcut method for dividing. And so here's how synthetic division works. First of all, you can only use it when you are dividing by something that starts with just an x. If it doesn't have just an x there, you can't do this shortcut. Okay? So here's how we use our shortcut. We take this number that's next to the x, and we take the opposite of it, and it goes up in the corner right here. So that's, we're going to put in a -3. That says +3, we put in a -3. Okay? Or that says +3. And then we take the coefficients and we write them down from this. So notice, this is where we have to be careful. We have a 1 coefficient for the x to the 4th, right? What's the coefficient for x cubed?
0.
0. And so if we know this is the x to the 4th, we have to make sure we also have an x cubed. What about for the x squared? What's the coefficient there? -10. And how about for the x? -2. And then the constant is 4. Now, these usually are not up here. I'm just putting there for us to keep putting them there for us to help keep track. But what happens is these are like place values, right? The last one is always the constant, and the next one will be the x's, the next one will be the x squareds, and then the x cubes, and the x to the 4th, and x to the 5th, or however far you go. So if you've got a missing term, you've got to make sure you put in a 0 for that spot. Just like in the number 107, you don't just write a 1 and a 7. You have to put a 0 in there so that we know the 1 is 100. Right? Does that make sense? It's the same thing here. If this 0 wasn't here, we would think this is x cubed because it wouldn't be over far enough. So that's where we have to be a little bit careful. All right. So after we get that set up, we're going to put a little gap, and then we're going to put a line underneath. Leave some space, a little bit of space there, enough to write some numbers. We're going to put a line underneath that. All right. Does everybody have this set up on your paper? All right. We're ready to go now. First step, it's really complicated, really difficult. We take this number and bring it down to the bottom. Whew, we made it. All right. No, just don't mess that one up. You just bring it down. You don't do anything with it. Just bring it down. Now, from here on, here's where the pattern starts. We take this number on the bottom and multiply it by the corner. So 1 times -3 is -3. That goes underneath the next number spot that you have. And now we add those two together. So 0 plus -3 is -3. So now we've got another number on the bottom. And just like last time, multiply by the corner. And so -3 times this -3 over here is what? 9. And it will go underneath the next number spot. And then what do you think we do with those? We're going to add them together. So -10 plus 9 is -1. So we've got another number on the bottom. We're going to multiply it by the corner number. -1 times -3 is +3. And that goes underneath the next number. And we're going to add those. So -2 plus 3 is what? 1. And what do you think we're going to do with that 1? Multiply by the -3. And that's -3. And then what do you think we're going to do with these? Add them. So again, the patterns, once you get this first number here, the pattern's the same. You just keep doing it until you get to the end. Right? Now that's great, but we know this can't be the answer because we should have some x's in our answer, right? So here's how we get the x's. Whatever the degree was originally, it was a 4, right? It always, always, always goes down by 1 when you do synthetic division. So the degree now is x cubed. That means this is 1x cubed. Then this is -3x squared. This is -1x plus 1. And what do you think this is at the end? Remainder 1. Or, again, we could write plus 1 over what we divided by, which is x plus 3. Right? We have either option there. Just what the director tell you to do if they specify one or the other. Okay? That kind of makes sense with that synthetic division? It's just a pattern, but it always works, but we can only use it if what we're dividing by starts with just an x. If there's a number in front of it, or if there's an exponent, we can't do it. It has to be just x plus something or x minus something. Okay? And we're going to have several more examples of synthetic division here tonight. So if nobody has any questions on this one, we'll go on to the next one. All right. So this time, keep this number here and dividing by x minus 3. So we got to check. And yes, we can see it just starts with an x, right? So we can use synthetic division. Notice it doesn't say to use synthetic division, but if we can use our shortcut, we'll go ahead and do it. So the next question that we have to ask ourselves is, what number should go up in this corner? A positive 3. Remember, it's always if you see this x minus 3, you got to change the sign. So this is going to be just a 3. And then we're going to have the highest power here is x cubed. So we're going to have a 5 for the x cubed. What are we going to have for the x squared? Negative 2. What are we going to have for the x? 0. And I say it out loud so you can be careful. Yeah, there's no x here, right? So we have to put in a 0. And then what are we going to have for the constant? 1. And we put a little gap and put our line underneath there. And the hardest step, what do we have to do first? Just drop the 5. The 5 just comes down and goes underneath here. Then what will we do with that 5? 5 times 3 is what? 15. So we put it underneath the next number, which is a negative 2. And what do we do with those? Add them. So negative 2 plus 15 is 13. And what do we do with the 13? Multiply by 3. Correct. And it's a 39, and it goes underneath here. And then we do what with those two? Add them. 0 plus 39 is 39. Okay, now this one you probably want to pull out your calculator for, but what is 39 times 3? 117? And then we add those and we get 118. Okay, now what does that mean our answer is going to be? It's going to be 5, but what's after the 5? X squared, because the degree, which is 3 originally, always goes down by 1. So now it's x squared. So that means the 13 is going to have what after it? X, and then the 39 is a constant, and the remainder is 118. Okay, does that make sense? And good, that's the right answer. So we're happy when we get the right answer. Any questions on that one? So if you can use your shortcut, go ahead. If you can't, then you just use the long division like we did on the first couple. Okay. Now, here's some applications of these properties that we're going to be looking at here. The first one says the remainder theorem. If the polynomial p of x is divided by x minus c, then the remainder is the value p of c. Let's go back to this example that we just did and see what this is telling us. Notice we've got a polynomial. It's divided by like x minus c. Okay. The c is 3. It's that number that we had in the corner, right? So what this tells us is p, if we view this as p of x, p of 3, in other words, if we put a 3 in for all of these x's and simplified it, p of 3 would equal the remainder. Now we've already done that work. What do we know the remainder is? 118. So there are going to be some problems on your homework where it gives you something like this. It says do p of 3. What they're really asking you to do is do the synthetic division, figure out what the remainder is, and then that's going to be your answer. So in other words, if you plugged in with a calculator, if you plugged in 3's for all those x's and simplified it, you would get 118. We're not going to go through and do it now. Just trust me, it will always work. Okay. When I was in college, I had to prove it. I don't remember how anymore because that was a long time ago. Okay. I could maybe remember eventually, but that's the idea. We're going to do our synthetic division and evaluate it that way. And so let me show you how this will work. So it says P, we're supposed to evaluate P of -4. So I know on your homework problem, it's just going to say P of -4, and then it will have a box, like it normally does, right? So here's what we're going to do when we see that. We're going to put, now here's where it's a little bit different. Notice there's no x plus or x minus, right? They're just telling you use -4. Does that make sense? So that's what we're actually going to do. We're just going to use -4 in the corner. There's no x plus or x minus. They're just telling us a number to use. We use it. Then we're going to go through here, and we've got, notice we've got x to the 4th. What is our coefficient for x to the 4th? 1. What's the coefficient for x cubed? 0. Make sure you watch out for those missing terms. What is our coefficient for x squared? -5. And for the x, 4. And then the constant is 12. And then we leave our little gap, right? So what are we going to do first? Drop the 1. Okay, then what do we do with the 1? Multiply by the -4, and that gives us -4. And we add those, and we get -4. And then what do we do after that? You guys are all doing the work with your calculators. I can see you doing it. We're going to multiply, right? So -4 times -4 is 16, and that goes right here. And then we add them, and we're going to get 11. And then what do we know about 11 times -4? -44. We add those, and we get -40. And -40 times -4 is going to be positive, and it's 160. And then we add 12 and 160, and we get 172. Okay? Now notice, we're using the remainder theorem to evaluate here. We don't have to write the whole answer. All we care about is the remainder. So that's what goes into our box, 172. Okay, we're not doing the full, I mean, we did the division, but we did the division to find the remainder so that we could use our remainder theorem. Okay, so you may want to put a star by those because I know that I was actually taught this lesson in my high school class today, and they were in trouble remembering that they just needed to put the remainder in there in the box. Okay, so that's how that one works. You can put a star by that example for when you get to those homework problems. Okay. Any questions on that? Does that make sense? So that means if you would put in a -4 for all of these and evaluate it, your answer would be 172. That's what the remainder theorem helps us do. Okay. So let's do another one. This time, we're evaluating P of -1. So what do we have to do? What's going to go in the corner? -1. They told us to use -1. That's what we use. And how about, what is the coefficient for x to the 4th? 2 for x cubed. 6 for x squared. -5. How about for x? 0. Be on the lookout for that. And then the constant, -59. So make sure you are aware. And just about everyone I did tonight, I put 0 in there because I want you to make sure you look for it, because you don't look for it. I mean, if it's not there, you don't have to worry about it. But if it is there and you don't see it, then you're going to get the wrong answer. Okay? So what is the first thing that we're going to do?
Bring down the 2.
Bring down the 2. And what do we do with the 2? Multiply by -1. So that gives us -2 right here. And what do we do with those 2? Add them. 6 and -2 is 4. What are we going to do with the 4? Multiply by the -1, and that is -4. Then what do we do with those 2? Add them, and we get -9. What do we do with the -9? Multiply, and it gives us positive 9. We add again, we get 9. And one more time, what do we do with the 9? Multiply, and we get negative 9. So then we're going to add these together. We get negative 68. Now, what is our answer to this problem? We want to figure out what p of negative 1 is. And what is it? Negative 68. That's all we have to write down is that remainder because we're using that remainder theorem. Okay? So we just identify the remainder, and that's going to go in the box when they're asking us to evaluate. So when you see something like this, and it's just evaluating that one number, put the one number in the corner, do your division. The answer is the remainder. Okay, any questions on that one? Have you gotten to the upside down pages yet? All right, so p of negative 1 is negative 68. All right, well, the other one we want to talk about here, another theorem, is called the factor theorem. And it's actually, this is where the remainder theorem becomes kind of important. We're going to kind of put it together with some stuff. So the factor theorem says a polynomial f of x has a factor x minus c if and only if f of c equals 0. So let's take this apart and make sure it's really not that profound of a statement, but it is always true. So what does it mean for something to be a factor of something else? What does that mean in math? Like if I tell you 6 is a factor of 30, what does that mean? It divides into 30 evenly, right? That means if you do 30 divided by 6, the remainder will be 0. It divides into it evenly, no remainder. So here's what that's saying. A polynomial f of x has a factor. It means it divides into it evenly. If and only if f of c equals 0. Well, we just figured out that if you use c and you plug it in, you get the remainder, right? And then what are they saying? Well, the remainder is 0. Well, we already knew that over here, right? Because that's what it means to factor. So they're saying these things always go together. If you get a remainder of 0, it has to be a factor. If it's a factor, the remainder will have to be 0. So again, it's not super profound, but it's something that we're going to use a lot because we're going to go through and we're going to do these synthetic divisions and we're going to find out the remainder, if the remainders are 0 or not. If the remainders are 0, we know it's a factor. If the remainder is not 0, we know it's not a factor. Okay, so that's where we're going to use this, and we're going to be using this for the next, well, tonight, and then not next week because we don't have class, but the week after that, we'll be coming back to this again. Okay, so let's look at this, and what this says is show that this this expression, binomial, x minus 2 is a factor, and this one is also a factor. So we're just going to do our synthetic division. Because notice the format here, x, right? They both just got x's. So we're going to use, I'm going to use the negative 2 first. And what do we know? X to the 4th has a coefficient of 2. This one is 7, negative 4, negative 27, and negative 18. This time, notice there was no missing terms, right? But we always look for them just in case. All right, we're going to put our line down here. And what do we do with the 2? Drop it down. And then this 2 gets multiplied by this negative 2, and we get negative 4. And we add them, and we get. Then we multiply them. Oh, actually, I taught this lesson yesterday, now that I think about it. Sorry. Then I multiply them, and I get negative 6. And I add them, and I get negative 10. And then we multiply the negative 10 times the negative 2, and we get positive 20. Uh-oh, I just messed something up. Hang on. What's going on here? 2, negative 4, 3, negative 6, negative 10, 20, 2, 7, negative 4, negative 27, negative 18. What am I doing here? Oh. Does everybody see what I did? something totally wrong. What did I do, Zach? I didn't change the sign. I'm like, why is this not coming out? Okay, let's fix this. See, even I make mistakes sometimes. All right, I have to erase some of these. Okay, the 2 still comes down, but when you multiply, it's a positive 4, which gives us a positive 11. Multiply that, we get 22. Add that, we get 18. I was so busy thinking about when I taught this lesson, I forgot how to do it. Okay, 18 times 2 is 36. And that gives us 9. And then 9 times 2 is 18. And notice what our remainder is. 0. Right? And that's what we needed, right? We needed the remainder to be 0. So we've just finished this part because we found out that it divided into there evenly, and we got a remainder of 0. Okay? Now I'm going to pause for just a second. I want to go back and I want to talk about something else. Let's say we have these. Remember how we had the radicals and we were breaking them up? So let's say we had the number 24 and we had to break it up. How would you start breaking that up? Okay, 6 and 4. Okay, and then how can we break up the 6? 2 and 3. And how do we break up the 4? 2 and 2. So the idea here is we keep breaking it up until we can't break it up any further, right? Now here's what's going on right here. We just divided this big thing by this, right? So at this point, we know that this, if we would write it out as a polynomial, this polynomial times this polynomial equals this polynomial. Our goal is to break it up like this, where we keep breaking it down into smaller and smaller pieces until we can't break it any further. So what we're going to do at this point is we're just going to start from here. We're going to ignore that remainder, but we're going to start from this polynomial, which is 2x cubed, 11x squared, 18x plus 9, right? And we're going to divide it by this one. So, see if I can do it correctly this time. What's going to go in the corner this time? A -3, because they gave us that factor. -3 goes right here. We draw our line underneath there. Drop the 2 again. What do we do with the 2? Times -3 is -6, and that gives us a 5. 5 times the -3 is -15. We add those, we get 3. 3 times the -3 is -9, which gives us a 0. So yay, we just showed that that one also divided into the original evenly, right? Because if it divides into this one, it had to have divided into the original one, right? You could have done it with the original. You could do it either order, it doesn't matter. But they will both divide into that evenly. So that's how we can show that those are both factors. Okay? Now, just to take it one step further, this is not part of the question. We're done. We're done with the question. But what we have just shown is that 2 times x plus 3 times this. Now, here's what's left here. Remember, this was x to the 4th. We divided once, and it went down to x cubed. We divide again, so what do you think it goes down to? X squared. So this is 2x squared plus 5x plus 3. These things multiply together. If we took time to do it, we're not. But if we multiply them together, we would get back to this. So that's the idea. When we do this synthetic division, we're breaking it down if we can, however far. I mean, when they do a problem like this, we're going to break it down, keep breaking it down further and further. Not so much tonight, but in a couple weeks. That's when we're going to do that. Okay? But yes, these are both factors since they divide in evenly, which means that their function values are both 0. Right? That's what the remainder tells us. If the remainder is 0, that's the function value here and the function value there. Okay? Does that make sense? All right. So Looking at this one, it says the polynomial p of x equal to that thing has a horizontal intercept at x equals 1/2 with a multiplicity of 2. Find the other x-intercepts. So what they're saying is 1/2 comma 0 is an intercept. It's a horizontal intercept, right? And they're saying it occurs twice, which also means that it's a 0 of the function. So we can do the same thing we've been doing. We can even do it with this fraction, 1/2. So what is the degree is 4, but what's the coefficient we have to start with here for our synthetic division? What's the first one going to be? 4, and then -4, and then 11. Yep, and then 12 and -3.
Only 1/2 has to be negative then. On the top.
So this one, now you have to be a little careful here. Notice they are just saying x equals. They're telling you what x equals. They're not saying it's a factor x plus or x minus.
Okay.
So we just use what they tell us. Yeah, I wasn't paying attention last time. I have to pay attention now, otherwise I'll goof up and get it wrong. But if they just tell you what x equals, or they put in parentheses for you like that, just remember, they use that number. Okay? But yes, be on the watch for switching that, because a lot of times people forget to switch it. Okay? So then, again, our process is we drop the 4, and you may want to use a calculator. Maybe these aren't too bad, but 4 times 1/2 is 2, right? Half of 4. That goes here. Add those, we get -2. -2 times 1/2 is -1. Add those, and we get -12. All right, what is -12 times 1/2? -6. We add those, and we get 6. And what is 6 times 1/2? 3. And so that's 0, which we knew it should be because they told us, right? So now, again, we're going to leave it where it is. We're going to keep breaking it down again. So we know that 1/2 has a multiplicity of 2, so we can use that 1/2 again. Remember, multiplicity means it happens more than once. So we're going to put in the 1/2 again and drop the 4 again. So 4 times 1/2 is 2. We add those, we get 0. 0 times 1/2 is 0. Add those, we get -12. -12 times 1/2 is -6. And we get 0. So yes, we knew it would because they told us, but it works twice. Now, what do we have left here? What is this polynomial? This is 4x to what power? Squared, because it was 4, right? It was x to the 4th. We divided once, it made it x cubed. We divided again, it makes it x squared. So this is 4x squared. The 0 tells us there's no x, right? This tells us there's going to be a -12. And then the remainder is 0, which we already knew. So we don't need that. But here's what we've got left. If we want to find the horizontal intercepts, remember we have to set it equal to 0. And now we're going to solve that. And this one isn't too bad. It's actually pretty nice. What would we do to try and solve that one and get the x by itself? Add 12? So 4x squared and 12. Then what would we do? Divide by 4. So x squared equals 3. That's supposed to be a 4 there. And then what would we do? A little bit trickier, but I know you guys know.
The little.
Yes, that thing. We take the square root of both sides. And so we're going to get x equals the square root of 3. But anytime we do this step, do you remember what we have to put in front of here? Plus or minus. Okay, now notice the question. Find the other intercepts. So they're not just saying solve. So we've got to write it as an ordered pair, right? So one of our answers is square root of 3, comma 0. And the other one will be negative square root of 3, comma 0. That's a 0. And those are the other two intercepts. We already knew the first ones were these, right? We already knew that one, but now we have the other two after we do our synthetic division. Okay, and like I said, that's not the main focus for tonight. You'll have a lot of other types of problems, but we're really going to do a lot of this once we get back after our break next week. Okay, and there's our intercepts, and that is the end. So we have 8 graded problems, and these are not due until 2 weeks from yesterday because we don't have class next week. I mean, you can come, but I won't be here. So 2 weeks from yesterday is when these are due. But again, I'd suggest don't probably wait until the last minute to do them. Try and get started on them early while you still remember what we're doing here. And that's it. Have a great spring break.